case. All right, recording this, and I'll post it for anybody who might need to review. I'm not sure if you're gonna have enough time, but let's suppose you can. All right. So, we're gonna try to cover. Well, again, this is not a new topic to us. This is just a revision. So we're gonna review these items, right? You're able to state the coordinates of a point on a coordinate plane. Be able to determine the gradient of a line given 2 points on the line, or any 2 points on the line. Calculate the length of a line segment using the Pythagorean theorem, right? Or the same formula that we use, square root of difference in the x squares plus the difference in the y coordinates squared, and find the square root of those. That's particular sum. So that's basically Pythagorean theorem, really. Okay, so we have the x squared plus the y squared. We square root that answer, and that's how we'll find the gradient. So now in terms of the x, we know that's going to be difference in the x's, right? Being squared plus the difference in the y's being squared. This is what I was saying earlier, so you can see it visually. So that's the formula for the length of a line. So if we have 2 points, A and B, we want to find the length of line segment AB, then this is the formula we use. In terms of the coordinates of a midpoint, then we use what? We find the average of the x, average of the y's, right? And so we're talking about this. X2 plus x1 over 2, y2 plus y1 over 2. And that will give us the midpoints. This will give us the average of the x coordinate, average of the y coordinate. All right, and this will be the midpoint. Capital M, by the way, for midpoint, right? And then we want to be able to determine the equation of a line in slope-intercept form. So the slope-intercept form is the y equal mx plus c. All right, so if you're given 2 points on the line, you should be able to find the gradient, find the y-intercept. All right, on the graph, we can do that as well. Just pick the y-intercept off the graph. A gradient at a point. Then, of course, if you have the gradient, then you're going to put y equal that gradient, x plus c. Then you're going to replace the x and y from the point that you're given. You're given a point, right? And you have the x coordinate and the y coordinate. You just basically replace the x and the y coordinates. And then you already have m, so you just maneuver these guys here to find your c value. Once you find the c value, just go back to the original equation and you put y equals the gradient that you have found, put the x, and then you put the c value that you have found, and that will be the equation in the slope-intercept form. All right, we're going to go through that though, don't worry. And then we're going to determine the equation of the line in the intercept form. And the intercept form, what is the intercept form? The intercept form is x over a plus y over c equal 1. Where a is the what? X-intercept. Notice it's over the x. It's underneath the x, I should say. And this is a y-intercept underneath the y. So this is where the graph cut both the x and y axis, right? So here we have our x and y axis. This point here is the x, the c, well, not the x, but the c, the y-intercept c. And this point here, A, is our x-intercept, where it cuts the x-axis. All right? And it's always equal 1, by the way, for the x-intercept form. Not the x-intercept, but the intercept form. Again, the intercept form has 2 intercepts, right? The x-intercept and the y-intercept. All right, and we also want to know how to find the equation of the parallel line, given a point on the parallel line to another line. We also want to find the equation of the perpendicular line to another line, given a point on that perpendicular line. And that's about it for that. Okay, so now in terms of coordinate geometry, I didn't mention this before, but I did say that it's used in real life. We have navigation and GPS system. I'm sure you know about GPS system, right? GPS uses coordinates to pinpoint locations on the earth, aiding navigation. cartography and map making. You can read more about that. Computer graphics and gaming, if you're into that, then coordinate geometry will be very useful. The coordinates are used to design and render images, video games, simulation, and virtual reality. Environments rely on coordinate geometry for visual representation. So we see how maths is important in gaming, right? And architecture and engineering. These persons use coordinate geometry in designing and constructing buildings. Also help with precise measurements, layout planning, and structural analysis. We also have physics and engineering sciences, right? Use coordinate geometry to model and analyze physical systems. So you see a wide range of that, right? We have agriculture and farming, right? So precision agriculture utilizes GPS coordinates to optimize farming practices. Farmers can plan crops rotation, monitor soil conditions, apply fertilizer with accuracy. If you're into business, if you want to be a business person, market researchers, analysts use coordinates to represent economic data graphically, right? Medical imaging. If you plan to be a doctor, in medical imaging, coordinate geometry is used to represent and analyze images produced by technology such as MRI, CT scans. It aids diagnosis, and treatment planning. Robotics and automation, if you're into that. Environmental science, all right? It helps to monitor climate change, study the ecosystems, and managing in natural sciences, if you're into science. And this one is for MJ particularly. He spoke about he wants to be a photographer. I don't see how this is going to be important to him. But here's talk about photography. Some brief points you can note. Framing and composition. Understanding coordinates helps in framing and composing photographs effectively. By knowing the position of elements in the frame, you can create virtually appealing and balanced compositions, right? That's photography. Another point in photography as well too. Many photo editing software tools use coordinates for precise adjustments. Right, so learning coordinate geometry can enhance your skills in using such softwares to edit and enhance images. Also, location tagging. Same photographer. In photography, basically, modern photography, location tagging is common. Knowledge of coordinates allow you to accurately tag locations where your photos were taken, which can benefit can be beneficial for building a professional portfolio and sharing your work. All right. Also, drone photography as well. If you ever explore drone photography, coordinates become crucial for navigation and capturing images for special locations. So we're seeing a bunch of other things in photogrammetry. All right. I mean, these are a whole lot of different things. You see how important coordinate geometry is. It's foundational for photogrammetry. All right, so if you really want to get into being a photographer, coordinate geometry will really help you in so many different ways. Now, so these are the formulae that you need to know for your test. Basically, we have 2 points. If you have any 2 points on a particular straight line, you can find the gradient between those 2 points, or in other words, a gradient of the line itself. And this is the formula: use y2 minus y1 over x2 minus x1. The length of the line segment, we discussed that earlier, right? It's going to be the square root of the sum of the squares of the difference between x's and y's. In terms of x's and y's, we're talking about the x coordinates and the y coordinates of those 2 points, right? And then we have the coordinates of the midpoint. It's going to be average of the x's, average of the y's. For part 4, the equation in the intercept form, x over the x-intercept plus y over the y-intercept equal 1. And we did highlight what that is all about, right? You have the y-axis, the x-axis. Where the graph cuts the y-axis, that's your y-intercept. Where it cuts the x-axis, that's your x-intercept. So A is the x-intercept and C is your y-intercept. And of course, if you're given this, you can actually find the gradient by finding the negative of the C value divided by the A value. And that's what it says here. It says here, right? So, going on point 5, you can move from the intercept form to the slope intercept form again by taking the negative of the c value divided by a, and that's how you find the gradient here. And once you have that, you can replace the m with negative c over a, and so you can say, well, you're using this form really, but it's still y equal mx plus c, just that the gradient is negative c over a from this form. Okay, so let's look at the perpendicular and parallel lines now. What do we say about parallel lines again? Well, if two lines are parallel, that means have the same slope and they will never meet, then they have the same gradient. All right, so if I call this m1, and we say the gradient of this line here, given by as m, is u over v, then the gradient of this line, let's call this the gradient for this line m2, is also u over v. In other words, m1 is the same as m2. Both gradients for these two lines respectively will be u over v, whatever numbers those are, u divided by v. Okay, and that's what it's saying here. The gradients are the same. In other words, they are equal. Now, what about perpendicular lines? For perpendicular lines, well, if you multiply their gradients, you're going to get -1. And what's the reason for that? Well, let's go back to that equation. Let's say equation for AB. Let's call this line AB, right? Let's call this line AB. And we're saying this gradient is u over v. If I have a line that passes through line AB, right? Passes through it at 90 degrees, right? Let's call that line PQ, right? PQ. Then line PQ, straight line or line, right? Line PQ will have a gradient because it passed through at 90 degrees. Its gradient will be the negative reciprocal. Now, obviously, if you have a line slope in this direction, right, going down this direction from top to bottom, let's go back to this. Let's say you're here and you're facing the screen. This is your right hand and this is your left hand, right? Once it's your right hand, once the slope is like it has the same orientation or similar orientation to your right hand, then it's going to be a positive gradient. Once it's like your left hand, it's a negative gradient. So if you look at line AB, it has a positive gradient, right? And so line PQ, because it's sloping the other way around, like a left hand diagonal, it's going to be a negative. All right, so one is positive, one is negative. So when two lines are perpendicular, one will be positive, one will have a positive gradient, the other will have a negative gradient. And this PQ obviously will be the negative because it's a left hand diagonal. And obviously we also mentioned that it's a negative reciprocal. So instead of being u over v, it will be v over u, the negative reciprocal. And also I mentioned that when you multiply the gradients of two lines that are perpendicular, you're going to get -1. Now how is that? Well, let's look at these two here, right? These two gradients from a pair of lines that are perpendicular. M1 is negative u over v. M2 is let me just go back over. M1 is actually u over v, and M2 is negative v over u. If I should simplify this, all right, let's see. U into u, what goes once? U into u goes once, right? Whatever number that is, they'll be the same in the numerator here and the denominator here, so they'll be able to cancel. V into v is 1, and v into v is 1. Same number here will be here as well. Now 1 times 1 is 1. 1 times 1 is 1. And a negative number times a positive number will be negative. So we end up with a -1. So when you multiply the gradients of two lines that are perpendicular, you get -1. Everybody's clear so far? Yes? No? Can somebody respond? I heard somebody, but they kind of cut off.
I said I have a question.
Oh yeah, sure. Go right ahead.
So, can you give an example of how to figure out the parallel lines?
Oh yes, definitely. We're gonna go to a question now. What I was doing here is just going over the theory. Just going through the theory, just to make sure that we remember those little points. Now when we do the questions, we're going to see how we're going to apply these little notes. So remember, if lines are parallel,
Okay.
major thing is to know that what? The gradients are equal because they're sloping the same way. Gradient just means slope. And so if they have the same measurement for the slope, that means they should be equal. And if they're perpendicular, then they'll be the negative reciprocal of each other. One being positive, one being negative, and reciprocal of each other. Okay, so here we have a question similar to the one you're going to get in the test. It says we have a straight line. As we can see, the blue line here, it crosses the x-axis at Q. So here we have the x-axis. Here we have the y-axis. So this straight line crosses the x-axis at Q and the y-axis at P. And we're asked to determine the coordinates of P. Okay, so now there's several ways to remember this. Let's look at point P. It has two coordinates, an x coordinate and a y coordinate. So when you ask for the coordinates of points, you want to give both the x coordinate and the y coordinate. All right, a location of something, you want to give where it's located in the x direction as well as the y direction. So if you look at point P, which is right here, it's on the y axis. What is the location in terms of x and y? Well, because it's on the y axis itself, that means it's the y coordinate. That 2 here is actually on the y axis, so that the y coordinate is 2. And once a point is on the x axis or the y axis itself, one of the coordinates will be 0. Okay, so in terms of the x coordinate, we look at where the point is and we go straight down towards the x axis and it hits the origin, and the origin, both coordinates are 0. But since we're only looking for the x coordinate, since we're going down on the x-axis, we know x will be 0. Another way to look at this is that if you're starting from 0, everything starts from the origin, and you want to get to point P, what would be your movement? Would you move to the left or the right if you're at the origin and you need to get to P? Would you move to the left or right? No. You move straight up to point P. And since you're not going to move left nor right, then what? You're not going to move left or right. So therefore, in terms of the x direction, it's just going to be 0. Because the x movement is left or right, based on the x-axis, right? Left, right. Well, this is right and this is left. We don't need to move left or right. So that's be 0 for x. But since we're going to move up now, up or down, that deals with the y-axis. But we're going to move 2 units up based on what we're seeing. We have a 1 here and we have a 2 here. So it's 1, 2 units up. So the y movement up is y equals 2. In other words, the y coordinate being 2. And we're going to use the same thing for the point Q. All right, here's point Q. Let's start from the origin. Now we always start with x and then y. Do I need to move? Well, let's start with x. In order for me to get to Q, I definitely would have to move to the right. So we're moving the x direction. Left or right is x direction. We're moving 1, 2, 3. I'm looking at the numbers to make sure that's the same amount of units. This is 1 unit based on the 1 here. So that's 1, 2, 3. 3 units to the right. So in the x direction to the right, that's positive 3. But since I'm already at Q, I will not need to move up nor down. So therefore, Q, well, in terms of the y coordinate, that's 0. Because from the origin, I just move straight to Q. I do not need to move up or down to get to Q. I'm already at Q. So that means the y coordinate is 0. And that makes sense. Okay, if you look at Q, right, and you want to find the y coordinate, you head towards the y axis, which is this, and it will hit the y axis at the origin, which is 0. But since it's on the x axis at 3. Now, once we understand that, what the next step is to label these points. So let us label those points. Right, let's label those points. This is going to be, we're going to choose one of the points. If we want to call that 1 and call this one the 2, that's fine. So this will be x1, y1. This will be what? x2, y2. Okay, and then we're going to use that to find the length of the line as well as the other formulae, right? We have midpoint, we have several others. So for the length of the line PQ, line segment PQ that is, because the length of the line PQ, we can't find that measurement. It goes on forever in the opposite directions, right? But just from point P to point Q, we call that a line segment. And its length will be what? Well, let's write the formula. That's the first thing we need to do. x2 minus x1 squared plus y2 minus y1 squared. Now remember to tell you that this is the Pythagoras theorem really, which is if you want to find the length of the hypotenuse is the square root of x squared plus y squared. And so all we did was to replace the x with the difference in the x's, and so we end up with difference in the x's squared instead of saying x squared, plus the y, we replace the y with the difference in the y's. Alright, so it's difference in the y's to be squared. Alright, now we could illustrate this on the graph, but because of time, we won't do that. Now we're going to basically input those values. Now x2 is actually what? x2 is 3. So we put 3 here minus x1, and x1 is what? 0. The y2, identifying it right here, which is going to be 0. And the y1, look for it based on your labeling. Let's go over that. Yeah, well, y1 is right here, which is 2. Now, again, just to be sure, use a calculator. Right? 3 minus 0. Well, you don't have to use a calculator for that, right? If you had 3, let's look at the number line. The x-axis has a number line to help us with in terms of directed numbers. Just the x-axis as a number line. If you add 3 and you shift 0 place to the left, well, 0 means you don't move at all, right? So you still add 3. So 3 minus 0 is simply 3. If you add 0, which is the origin, and you shift 2 places to the left, indicated by minus 2. So if you add 0 and you subtract 2, that means you shift 2 places to the left. So that's going to be 1, 2. And you end up at what? Negative 2. So if you add 0, shift 2 places to the left, you end up at negative 2. So 0 minus 2 is negative 2. Okay, so here comes this part. Now be careful with this part. You're squaring numbers. Every number that you square should always be positive. So once the power is an even number, no matter what that number is in bracket, it will be a positive number. Okay, so 3 squared is 3 times 3, which is 9. Verify with the calculator. Negative 2 times negative 2. Because the power is an even number, your answer will be a positive answer. So negative 2 times negative 2, that's positive 4. And this will give us the square root of 13. Alright, and this should be 3.6055, etc. Now, let's say we want 3 significant figures. This is the first significant figure, which is going to be what? The first significant figure here is 3. The second is 6. 0 in between non-zero digits are significant. And so this 0 is the third significant figure. I only want 3 significant figures. That means I'm chopping off these. Always look at the very first digit you're chopping off. If it's 5, 6, etc., then we're going to add 1 to the last digit we want. So we want up to the 3. So our answer is going to be 3.61. And this is corrected to 3 significant figures. And in bracket you can put corrected to 3 significant figures, right? Okay, let's move on now. Now everybody's clear on that? I think everybody should be clear on that. Any question on that, or can we move on?
Yep.
Okay, so for the midpoint now.
Move on.
Alright, thank you. So for the midpoint now, we need to find the x-coordinate of this midpoint as well as the y-coordinate of this midpoint. Now if you look at the graph here, we have the point P and we have point Q. So the midpoint is going to be somewhere at the center, right? The center somewhere here, but we're not really sure. Is it here? Is it here? Is it there? We're not sure. But let's see where the midpoint between P and Q is using this formula. The average of the x means you're going to add the x values, just like when you find the average of 2 tests you're given. You add them and divide by 2, right? So we find the average of the x and the average of the y coordinates for both points. And so let's put those values in now. Just remember average, add and divide by 2. So in terms of the x coordinate, x2 is 3. We'll identify it right here. I'm going to add x1 is 0. y2 is 0. And y1 is 2. Now what is 3? So we're going to do the numerator first. 3 plus 0 is 3. So that will give me 3 over 2, or 3 halves. 0 plus 2 is 2, so that's 2 halves. And if you have 2 halves, you have a whole, right? Now converting 3 halves into a mixed number, because the top is heavier than the bottom, so we call it a top-heavy fraction, or an improper fraction. right? So that means we can say 2 into 3 goes once, remainder 1 over 2. Only for top heavy fractions we do that too, right? Because they're improper fractions. Now 2 into 2 goes once, there's no remainder, so we just leave it like that. Now if you look at the graph now, where is the point? Where is this midpoint located? Capital M, by the way, for midpoint, capital M. 1.5 or 1.5 is where? Well, look at the graph. On the x-axis, because the first coordinate is the x-coordinate, 1.5 is right between 1 and 2, so that's right between here. Right between 1 and 2 is right here. So we go up to the graph of a straight line, and it's right here. And notice where the point is on the graph now, we go across to the y-axis. Notice where it hits it. It hits it at 1. And isn't that what we have? What we have found? 1.5 for x, and for y is 1. Yes, that's the midpoint. 1.5, 1. So that's the midpoint. Everybody's clear on that? Can we move on?
Yeah.
All right. Okay. Anybody want to write that down, or you're good? You're taking a picture of it. Okay. Okay. All right. Good. So let's move on now to the gradient. Okay. So I'm moving on to a different slide. So I'm going to just write back the coordinates for P and Q, right? So we still need the same coordinates for P and for Q. All right. So P. What are the coordinates for P? Again, P is right here. X value is 0. Any point on the y-axis, X is 0. You know, the opposite one is 0. Any point on the y-axis, X is 0, and so Y is 2. Any point on the x-axis, Y is 0. The other letter will be 0. So it's on the x-axis, so the Y is 0. But since on the x-axis at 3, then X is 3. I remember we said we want to label, right? X1, Y1, X2, Y2. All right, you don't have to do this in the exam because I mean it's just one. You know, you can actually look at the page and see where you're at. All right, so the gradient formula now, because the midpoint really, right, is a capital M, 1.5, 1. So we got it for it, right? The gradient is a small letter m, common letter m. Remember that, and it's y2 minus y1 over x2 minus x1. And so now we're gonna substitute the values in. Notice for all these formula we use in the same, actually formulas or formulae. For all these formulae, we utilize in the same values, okay, in terms of coordinates. Y2 is 0, minus y1 is 2. X2 is 3, minus x1 is 0. And so 0 minus 2, again, if you go at the origin at 0, and you subtract 2, you go 2 to the left, you're at negative 2. So that's going to be negative 2 for the numerator. And 3 minus 0, if you add 3 and you subtract 0, I mean you don't move at all. So that's negative 2 thirds. That's the gradient. Okay? Now, the equation of the line PQ in the slope-intercept form. The slope-intercept form is y equals, you have the slope, which is m. Another name for the slope is the gradient. X plus the intercept is c. So this is really the gradient y-intercept form, because you have the gradient, which is the slope, and the c, which is the y-intercept. So we need the equation of PQ. We want to identify its gradient and its y-intercept. We already have the gradient. We found the gradient in D, part D here, which is what? Negative 2 thirds. And we want C now. Now, once you have the graph, you can see where the graph cuts the y-axis. And this graph cuts the y-axis at what? At 2. So you just put 2 right there. Okay? And that's it. You have the gradient, which is negative 2 over 3. Just the number alone is the gradient, okay? And C is where it's cut the y-axis at 2. And so we're done. Now, for those persons who probably do not like to take the y-intercept off the graph, if you want to do it the longer way, sure, you could. Negative 2 thirds, which I don't suggest you do. Only if you're not given a graph, then you probably would have to plug a point in it. Now, by the way, once one of the points starts at 0, as in the x-coordinate, then the other coordinate is the y-intercept, once it's on the graph. So 0, C is the y-intercept point. So P is actually the y-intercept point. So this is actually a y-intercept point with coordinates 0, 2. Okay? So you could just simply recognize that this is the y-intercept from the y-intercept point of 2, which that's the y-intercept c, so 0, c. Okay, just to mention that so you guys remember that. Once you start with 0, then the y-coordinate is the y-intercept. But just in case you didn't know that and you want to substitute, let's use q, the points for q. Let's use 3, 0. We're going to substitute that into the equation. When if this is, well, 3 is x and y 0. So let's put 0 for y, negative 2 over 3. X is 3, right? Put plus c there. Now we're going to say 3 into 3 goes once, right? 3 into 3 goes once. And 3 into 3 goes once. And simplifying that, what would we get? Well, we'll get what a 0 that we have here for the y. Let's put that 0 down here. And this is negative 2. We didn't cancel negative 2. Remember, we canceled the 3 with 3, right? The numerator from negative 2/3. Well, not numerator. The denominator from negative 2/3 cancels out the whole number here, a number by itself. Every number is really a numerator if it doesn't have a denominator shown. So this is 3 into 3 goes once. 3 into 3 goes once. And negative 2 times 1 is negative 2. Back here plus c. Now to isolate c, we need to remove this negative 2. How do we remove the negative 2, guys? Well, 2 ways. We can use the balance method by adding 2 to both sides. And what this does, this will give us 0 on the left hand side. So 0 plus c, which is c. That means negative 2 cancel positive 2. And 0 plus 2 is 2, so we have c equals 2. The other technique to use, which you probably might be more familiar with, is to simply transpose the negative 2 to the other side, and it becomes what? A positive 2. So it's 0 plus 2. Negative 2 transposed as positive 2, leaving c isolated. So 2 plus 0 is 2. So the equation that we're looking for PQ, in this case, will be y equals the gradient which we found earlier. Put back the x now, and the c is positive 2. That's it. Now we also asked to form the equation of line PQ in the intercept form. And remember, the intercept form is what? X over a plus y over c equals 1. So it's going to be what? X divided by the x-intercept. What's the x-intercept? Looking at the graph, it's 3. What is the y-intercept? Because the y-axis is at 2. So it's y over 2 equals 1. And that's it for part D, part E, and part F. Any questions on that, or should I move to now the parallel and perpendicular line, the last part of this lesson? Any question? Anyone? Okay, so we're gonna move along then. Now we're at F now, so we're looking at the coordinates of F being 0, 2, and Q being 3, 0. Just want to remember what that those are. Just in the event we need to use them. Now let's look at this. We're asked to determine the what? The last part, or second to last part, F. We have G as well. Determine the equation of line ST. Okay, we have not seen that line yet because this line that we've been dealing with is line PQ, right? And let's write down what line PQ is again. Let's just make sure. And it's good to always write the equation by the graph itself. Negative 2/3 x plus 2, right? Remember, 2 is right because the y-axis, right? And negative 2/3 is just the gradient. Okay, so now, for PQ, we know the equation is y equals negative 2/3 x plus 2. So now we have this line ST. We don't know, we're not seeing that line. But what we're told though is that ST, the line ST, is parallel, and this is how you write it, guys. The line ST, or PQ, is parallel, right? It's parallel to the line, probably can use this. It's parallel to the line ST, right? Both of these two lines are parallel to each other. Okay? And since they're parallel, what do we know about parallel lines? Parallel lines have the same what? They have the same steepness. They have the same gradient. Very good. They have the same gradient. Okay? They have the same gradient. I remember, gradient is just a measure of how steep the line is. So if this line is steep because it's always slanted, then a line that's parallel to it should have the same steepness. Okay? And we're told that this line ST, it passes through where? The origin. Now for you to determine the equation of that line, we need a point on that line. We need a point on line ST. Are we given a point on ST? Well, if ST passes through the origin, that means the origin is on ST. Right? So, do we know the coordinates of the origin, guys? What are the coordinates of the origin? The x and y coordinate of the origin. Can somebody just tell me that quickly? What is the x coordinate of the origin and the y coordinate? And just for as a reminder, the origin is where the y-axis and the x-axis cross each other. So we're looking at this point right here. This is the origin, where both the x and y-axis cross each other. Anybody want to tell me what are the coordinates of that point? Quickly.
0.
0 for the x. And what about the y? What about the y coordinate? What's the y coordinate?
0.
Very good. So the origin has two coordinates, the x coordinate and the y coordinate. Every point has two coordinates. So the x coordinate is 0 and the y coordinate is 0. Okay? So therefore, let's go on now. So we know the gradient of line ST. Why? Since ST is parallel to PQ, they have the same gradient. So we can go right ahead and write the gradient for ST. It's the same as PQ. It's the same as PQ. Why? Because they are parallel. They have the same gradient. And you guys are doing well so far. You guys mentioned that. So, but we need to know what we need to find. What else we need to find? So we have the gradient for ST. Now we need what? The y-intercept. But we told it passes through the origin. Yeah. So what's the y-intercept? What's the value of the y-intercept? If the 0. Very good. Because the graph passes through the origin. Right? So here we have line ST. Right? It passes through the origin. And it's what? It's parallel. It's parallel to line PQ. This is the blue line is line PQ. And this looks like black line here is line ST. Okay? I can just put S somewhere and T somewhere. Doesn't matter where I have it, right? Line ST. So let me just say this is T here. So line ST passes through the origin and is parallel. So these two lines are parallel to each other. Yeah? And since it passes through since it intercepts the y-axis at 0, then we can just simply replace C with 0. Now, of course, if you're adding 0 to any quantity, you're going to get back that same quantity, isn't it? So I can simply write this equation as y equals negative 2/3 x. We do not need to put the plus 0, because adding 0 to this quantity here will give us back this same quantity. It's like saying 3 plus 0. Do I leave it as that? No, I can just put 3. That means the plus 0 is not necessary as the final answer. So the same thing with the negative 2/3 x plus 0. The plus 0 is not necessary as part of the final answer. So when you see an equation looking like this, just know that in the form of y equal mx plus c, and you're only seeing y equals some value x, like for example, y equals 5x, just know that the y-intercept is 0. That means the graph passes through the origin at 0. It's just that we don't need it. While the gradient is 5, the y-intercept will be a 0 if you don't see that number on it. Okay, that was just an example, guys. Okay, so now we know that this is the equation of what? Line ST. Okay, so some person might get a little confused with that, saying, okay, I don't see how we got 0. But I was just explaining, the graph cuts through the y-axis at 0. So C is 0. If you want to do it a different way, sure. Because it passes through this point 0, 0, then we can substitute 0, 0 into the equation that we have here to find C. Well, y is 0 in this case. So to pass through x and y means 0, 0. And x is also 0. And so we're going to try to find C. 0 is equal to, now what is 0 times negative 2/3? 0 times any quantity is simply 0. And any value plus 0 is that same value. So 0 plus c is still c. So c is equal to, put back the y coordinate, c0. So when we were to substitute 0 into the y equal mx plus c, we have y equals the gradient, put back the x, and c will be 0. I do not need to put plus 0. So this is my equation. Alright, everybody's clear on that?
Yes, sir.
Okay, so if I don't give you the origin, if I give you 3, 2 for instance, like let's say I told it passes through the point 3, 2, you would replace y with 2, and you replace the x with 3, and you find c, and then you plug it in, and you put back y equals negative 2 over 3x, and the c value found from substituting 3, 2, you put it here, and that's it. But since it's 0, 0, you know, you can put the 0, 0 and get your value as well. So sometimes CXC does that. They say the origin. You just have to remember that the origin has coordinate 0. They're not going to tell you they're not going to give you the coordinate of the origin. They want to know that, they want to see that you actually know that the origin is really has coordinates 0, 0. So for the final part of this lesson, let's go now to right, this perpendicular line. But before we go there, let's look at the question. Determine the equation of the line JK. So here I have this new line. We know this is line ST, right? So we're not dealing with ST anymore. We're not dealing with the line ST anymore. We're looking at this new line JK that is perpendicular. In other words, cuts line PQ at 90 degrees. And it passes through the point 2, 1. Let's identify the point 2, 1 on this graph here, on this coordinate plane here. Okay, this is my y-axis, my x-axis. Okay, so point 2, 1 is here, right? So from the origin, I go off to 2, right? Since x is 2, so we go to the right at 2. And y is 1, positive 1, so go up once. And so that lands me right here. So this is my point 2, 1. So this line that is perpendicular will pass through this point 2, 1, right? And if it's perpendicular, if this line is slanted this way, for it to cut at 90 degrees, it probably cut through here, something like this, right? But agree with that? We'll cut it at 90 degrees. And obviously, since these two lines are parallel, it'll also cut this one at 90 degrees as well. But our focus is PQ, right? That this line will be perpendicular. In other words, cut it at 90 degrees, or make a right angle with it, in other words. All right, so this is how it will turn. And it's a right hand diagonal, so this will be a positive gradient, while this has a what? A negative gradient. The equation of this line is negative 2/3 x plus 2. Okay, so let us look now about this line PQ, JK, sorry. So PQ, go back to PQ again. Equation is y equals negative 2/3 x plus 2. Now the line JK, let's put the actual form of the line itself in the slope intercept form first. Okay, what do we know about this JK? Well, what we need is to find M and C. And we just substitute them and we're good. But where do we start? Can somebody tell me? Anyone? You're writing the exam tomorrow. Where would we start? Where would you start? Find the gradient first, yes. Okay, so I'm in this exam sitting down trying to figure out, okay, line PQ has a gradient of negative 2/3, right? Remember the form of y equal mx plus c. This line PQ here that we're seeing here, right here, has a gradient of negative 2/3, right? I think I should write it horizontal, this division line, very important. Sometimes I get confused. Okay, so since JK is perpendicular, right? This is the symbol for perpendicular line. Since JK is perpendicular to PQ, I can also write it like this, right? Doesn't matter which one you put first. Since JK is perpendicular to PQ, what do we know about their gradients? Anybody? What do we know about their gradients? Can somebody tell me about two lines that are perpendicular? Or do I have to go back to the notes?
their gradients equal -1?
They're not equal to -1. They're not equal. What about them equal -1? What you have to do to the gradients to get -1?
Multiply them.
Right, so we say the product of their gradients is -1. Product is the result from multiplication, right? So the product of their gradients, in other words, the result from multiplying their gradients is -1. So if I should multiply the gradients of these two lines, so we can do it several ways. We can say, okay, let's call JK, let's say the gradient is M2. And gradient of PQ, let's call it M1. When I multiply them, I get -1. So I do not know what M2 is, but I know M1, which is the gradient for PQ, is -2/3. Alright, so I can replace that. So to find M2, I can transpose this to the other side, right? So M2 is equal to -1. When you transpose a fraction to the other side, you can keep the same multiplication, but upturn it. And what you will end up with is what? You end up with this -1.
The reciprocal?
The reciprocal, yeah. Alright, so the gradient of PQ is -2/3. Alright, and let's make sure I am right here. Okay, so this will be right. Right, so that goes over. And so as the negative, if you flip you don't change the sign because you're not changing from subtraction to addition. You're actually changing from you basically move using the reciprocal. A better way to actually do this so you don't get confused, because I know you're gonna get confused here. So a better way to do this is to, let me show you. You multiply both sides by the reciprocal to remove it. So I'm going to multiply this side by 3/2. Right, that's -3/2. Right, and then multiply this side as well by -3/2. So the 2's cancel, numerator and denominator. The 3's cancel, numerator and denominator. And negative times negative is positive. So that's being +1. That's M2 times +1. And negative times negative is positive over here. And 1 times 3/2 is still 3/2. So we have M2 equals 3/2. Because 1 times M2 is still M2. So it's 3/2 we get. Now, of course, you don't want to go through all that to do that. That is too much, right? But I can show you in the end that the two answers we get, when you multiply them, you get -1. So here's a faster way. Just simply, as we learn in class, just simply do this. One moment. Let's go back. Since this gradient is of -2, since the gradient of PQ is -2, right? Then for JK, it will be the negative reciprocal. Meaning that if this one is negative, the gradient of JK must be what? A positive gradient. And it must be the reciprocal of 2/3, which is 3/2. And that's it. Simple as that. The gradient of PQ is -2/3. The gradient of JK must be the negative reciprocal, meaning negative of this negative is positive, right? In other words, they must have opposite signs. So this one must be a negative. And we reciprocate. And that's it. Now, I need now to find what C is. So to find C, what must I do, guys? Tell me. In order for me to find C, what must I do? If I'm in the exam, you're in the exam room, you found, you know,
Y and X.
yeah, we need to do what? Replace Y and X. Now, how are we going to replace Y and X? Or should I say, what values we're going to use for Y and X?
2 and 1.
2 and 1, yes, 2 and 1. Very good. We're going to use 2 and 1. So the X is 2, the Y X coordinate is 2, and the Y coordinate is 1. So where I have Y, I'm going to put 1. And where I have X, I'm going to put 2. Okay, so the 2 and 1 just simply mean is a point on the line JK. Right, we're told that JK passes through the point 2, 1. And so we can, so any point on that line JK, we can take the X coordinate and the corresponding Y coordinate, right, of that same point and plug it in the equation where X and Y is, actually where X and Y are, and then I will be able to solve for C. So let's do this. Put back the 1. Now, how do we cancel this part here? This is made easy. Notice that we have a denominator of 2 and and we have a whole number, so we can cancel, right? So 2 goes into 2 once, and 2 goes into 2, which 2 over 1 really. 2 into 2 goes once as well. And so 3 times 1 is 3. And so we get 3 plus c. Next step is to transpose the 3 to the other side. And once we transpose a positive 3 to the other side, we're going to get a negative 3. Okay? So we win 1 minus 3. Technically, it's really plus 3. So if in fact 3 plus c is same as c plus 3. So when we transpose this 3, we're really saying we're transposing plus 3. Okay? That 3 plus c is same as c plus 3. So when we transpose a plus 3 to the other side, it becomes a minus 3. And so what we have here is 1 minus 3, which is negative 2. Again, if you had 1 on the number line, which is right here, and you subtract 3, you're going to go 3 units to the right. You're going to go 3 units. 1, 2, 3. So you have negative 2, as we got here. So c is negative 2. Okay, so now we can actually write the equation of this perpendicular line. Okay, so let's look at this perpendicular line from a graphical standpoint. All right, so here we said we have the point 2, 1. So this perpendicular line should pass through the point 2, 1. And we just discovered that what? That it will cut the y-axis at what? It will cut the y-axis at c, right? Which is negative 2. So it should cut through the y-axis right here at negative 2. So there we have the line, purple line. It cuts through the y-axis at negative 2, and it passes through the point 2, 1. Okay, so you can see that this is a, and if you look at it, it cuts through point 2, 1, and it cuts the y-axis at negative 2 as we calculated. It's very accurate. Notice that it looks like a right angle for real, right? If you form a circle out of this, you can clearly see that these two parts on top here will be equal. All right, so this will be 90 degrees, 90 degrees, 90 degrees, another 90 degrees. You form a circle out of this. So 360 degrees, a full circle. But the point here, this is 90 degrees. You can see it looks very square, or right angle, right? Forms a right angle. All right, so that's it. Well, before we go, let's check this out. Did we really write the equation? It said determine the equation of line JK. We didn't. We only found where it cuts the y-axis. So we have to make sure that we state that the equation of the line JK is y equals, replace the m with where we find negative 2 over 3. Negative 2 over, hold a second. 2 over 3, negative 2 over 3 is PQ. JK is
3 over 2. 3 over 2.
Thank you. It's 3 over 2, right? So this one here, the gradient is negative 3 over 2. This one here is positive. So y equals the positive 3 over 2. Reciprocate the 2/3 x, and where it cuts the y-axis, it's minus 2. So negative 3, so y equals 3 over 2 x minus 2. Okay, and that's it. That's it. So let's quickly review quickly. What's the first thing we did here? We wrote the equation for PQ just to identify the gradient of it, because we know the gradient of JK. Since JK is perpendicular to PQ, mean that these guys meet at what, 90 degrees? And so we know that the gradient has to be it has to have what? The opposite sign, which is positive, and reciprocate 2/3, we get 3 over 2. And so we plug that in where m is. Where m is, we replace m with that, right? Replace m here with 3 over 2. And the c, now we need to find c. So how do we find the c? Well, we know a point on JK, which is 2, 1. So we replace the x with 2. Replace the y with 1. And that allows us to find the value of c, since c is the only unknown in this part of the equation. So now 3/2 of 2. 2 cancels 2, give you 1. Basically 2 into 2 goes 1. And now 3 times 1 is just 3. So we write back the 2 here that we have, write back the 1 that we have here. And this work out, the 3/2 of 2 is just simply 3. And put back the plus c. Then we transpose the plus 3 over as minus 3. And 1 minus 3 is negative 2. Just be careful of that in your exam. Use a calculator. Answer C is negative 2. Telling us that JK, the line JK, crosses the y-axis at negative 2. So here we have the y-axis. We look for negative 2. This is where JK crosses it. But it also passes through the point, what? 2, 1. We identify 2, 1, which is right here. Okay, and we can definitely see that it cuts it at 90 degrees. And when you're writing the equation, please remember, put y equals the gradient that you found, x, and the c value where it cuts the y-axis. And that's it. Okay, so guys, any question?
No.
Okay. All right. So everybody's good then?